In this unit, we examine the ordinary snowflake and a quiet, astonishing claim that its shape is not decoration. It is a message, and if you know the code, you can read it. You have heard all your life that no two snowflakes are alike, and it is very nearly true, but there is a second fact, hiding in plain sight beside the first, that almost no one stops to wonder about, and once you see it, you cannot unsee it. Today we learn what a snowflake is actually saying. Part 1. The thing on your sleeve. Catch one. Look closely before it melts. A tiny six-pointed star, etched with a delicacy no jeweler could match. And you already know the saying, that in all the snow that has ever fallen, no two have ever been exactly the same. But now hold that thought up to the light and turn it. If every snowflake is different, utterly, endlessly different, then why is every single one of them six-sided? Not 5, not 7, 6, always 6. There it is, the chaos and the order in the very same object. Infinite variety on a frame that never ever changes. That is not a coincidence. That is a clue. Part 2. A physicist in the snow. Our story turns to the north of Japan, to the island of Hokkaido, and to the year 1932. There, a physicist named Ukichiro Nakaya faced a problem that most people would not even call a problem. His university had no funds for grand equipment, but it had in great supply one thing: snow. So Nakaya decided to take snow seriously, not as weather, as data. He went out into the cold with a camera and a microscope, and he began to photograph falling crystals. 1, then 100, then thousands of them, and as the photographs piled up, he did the patient thing, the almost stubborn thing that turns a mystery into a science. He sorted them: needles, columns, flat plates, great branching stars. Slowly, out of the endless variety, order appeared. The countless shapes fell into roughly 40 distinct types. And Nakaya began to suspect that something was choosing between them, that the shape was not random at all. Part 3. The two dials. What was choosing? The answer begins with one fact about ice. Frozen water is not a smooth solid. Its molecules lock together in a rigid, six-sided lattice, a honeycomb, repeated. That hexagon is the secret frame. That is why the frame is always 6. That part never changes. But how the crystal grows out from that frame, that is set by the air it grows in. And Nakaya found the growth answers to just 2 dials. The first is temperature. The second is how much moisture is packed into the air around it. Turn the temperature dial and the very same molecule changes its mind about how to build. A little below freezing, it spreads out flat into plates and stars. Colder, around 5 degrees below zero, it stops spreading and reaches instead, growing long into slender needles and hollow columns. Colder still, near 15 below, it throws out arms again, the grand, branching, six-pointed dendrites, the ones we cut from folded paper as children. Same water, same hexagon, different air, different letter. Part 4. The diagram. And here is where a patient man made something permanent. Nakaya did not just watch the snowfall and guess. In his laboratory, he built the cold and the moisture by hand, and he grew snow crystals artificially, the first person ever to do so, turning each dial on purpose to see what shape came out. Set the cold near 15 below, add plenty of moisture, and a perfect 6-armed star grew on command. Change the dials, and the shape changed to match every time. He plotted it all onto a single chart. Temperature along one edge, moisture along the other, and every crystal type in its proper square. We call it the Nakaya diagram, and a diagram like that is a strange and powerful thing. Because a chart that turns weather into a shape can also be read backwards, and turn a shape back into weather. Part 5. Reading the letter. So let us do it. Let us read 1. You are holding a wide, flat, 6-pointed star, all delicate branches, no columns, no needles. You look at the diagram and you run it in reverse. That shape only grows in one narrow place. Air about 15 degrees below freezing, rich with moisture. And that air was not down here where you are standing. It was thousands of feet above your head. So this crystal is a record. It tells you that high above you, in a place no thermometer was watching, the air sat at 15 below, heavy with water, And it drifted down through that exact weather, growing its arms as it fell and carried the news all the way to your sleeve. That is what Nakaya meant in the single most beautiful sentence a physicist has ever written about the weather. A snow crystal, he said, is a letter sent from the sky. And now you can read it, not the poetry of it, the letter itself, the temperature, the moisture, the whole quiet story of its fall, written in ice, addressed to anyone patient enough to learn the alphabet. The review card. And so we have learned that snow keeps a diary. Every flake is built on the same unchanging six-sided frame, and then written over in the exact hand of the sky it fell through. Plates near freezing, needles in the deeper cold, six-armed stars in the moist air near 15 below. One man with a camera and a great deal of patience taught us to read weather no one had measured, off a thing that lands on your sleeve and melts in a second. The world writes its history into the smallest things. We need only learn its hand. Class dismissed. And if a record kept inside a living, growing thing intrigued you, go and read the unit on the barcode hidden in tree rings.